Okay, good evening, everyone. Thank you for listening my presentation. This evening, I would like to present our paper as collaboration with my student. So I would like to share the paper presentation. This is the PowerPoint of our paper. So our team is include. We have five students. They are computer science students, where they have some final project to make the applications regarding with the related with their knowledge regarding with the computer science. So in this case, those students they try to look at what become the current problem in on daily basis. In this case, we try to look at the using of mobile application for pet road use. If you already know, this is a current problem for the big city because there's a traffic jams. Yeah, there's a lot of congestions, and some of the place they're using the toll roads, and some other we have in Jakarta. Actually, we have what we call the busway. Yeah, so sometimes there's a lot of people they can use that busway. So in this case, our students try to do the research and try to propose how can using that kinds of tool use without needed try to look at what the difference here. So our teams from Muhammad Rizkio Harliano, Muhammad Afif, Hafiz Ramadhani, Tanto Harsono Iwan, Rian Koswara, and me, Hercules Hendrik Warners. We are from computer science student, and I am from computer science department. This is the introductions. Yeah, if we look at the toll roads, this is very much needed and important in urban area. Yeah, of course, we already know that the toll roads, yeah, or if in Jakarta, we have what we call the busway. Yeah? This is the way that we can try to do the using the mass transportation, such as like bus. So everyone can use. However, there's still a lot of congestion and traffic jam around the Jakarta city. So in this case, we will look at sometimes and the busway roads, there is no vehicles, there's no bus uh, using that kinds of busway. Yeah. So in this case, we try to look at how the people can use that road in times when there is no people that use, there is no bus that go through that way. So in this case, we try to propose something like that. Yeah. However, the frequent occurrence of congestion on toll road creates a new problem and obscure the meaning of the use of toll road as expressways. Yeah. So this is if we look at the people to choose using the toll road because they want to free from the congestion or free from traffic jam. However, there's some still congestion and traffic jams in toll roads. Yeah. And also there's some problem as well. Tapping the e-toll card at the entry and exit gate takes time. Yeah, of course, we already know that we need time to open our car windows and try to tap the cards. Yeah, sometimes there's a problem with our card, yeah, or sometimes there's a problem with the machine to reach the cards. Yeah, so it takes time. Yeah. And at the end of the day, tapping the e-toll card at the toll entry and exit gate creates a queue of vehicle. Of course, we just make a new another uh, sequence line for the card here for the vehicles here. So in this case, we try to propose a mobile applications and route prediction model based on Dijkstra algorithm. So we try to make the application where the user do not need to try to tap their card when they try to enter the gate, the toll gates, or when they exit from the toll gates. Yeah. And then of course the price will be decided on which type of the car passed by the gate, and the algorithm predict the best possible route based on the number of cars on the highway. Yeah. And this is our proposed use case diagram. Yeah. If we already know that use case diagram, this is part of the UML, Unified Modeling Language, which is using how to model the system, that the proposed system. In this case, we have some activity in this use case. such as the user can top up the balance, yeah, so they can try to enter what kinds of the amounts of the money that they will input in the accounts, yeah. And then of course they can select routes, yeah, where they will try to go and what become the destination. And of course there's some possibility. We look at here, we have an include in use case. This is means that this is the activity that people can try to look at, yeah. This is the something that requirement that they can do it using the view the map as the complement for selecting routes, yeah. And then we have a security pin. This is for the purpose when the user using this application, so they can make secure the application by securing their pins. And of course, they have some possibility to update their pin. For the temporary, we just only using the pin. For the next, we try to apply for using some other biometric identification, such as using face recognition or fingerprint recognition. Yeah. And of course the user they can view their account here, yeah. And as one the other advantage, we try to make a point for each transaction use have been done by the users, yeah, so they can redeem the points, yeah. And then after they redeem the point, they can get the voucher. They can try, we try to make the collaboration between this application with some e-commerce application, so we can get the voucher from that e-commerce, or the what we call the marketplace, yeah, something like that. So they can spend their voucher on that marketplace, yeah, that related or a company marketplace, yeah. And then of course the user can show the transaction history here, yeah, regarding they want to know about what where they have done, what kind of activity that they use or to pay the top up balance in this case, yeah. And then for the admin, they can input toll route and the cost. Yeah, so they maintain what kinds of the toll route and what the cost for each is the way kinds of type of vehicles. Yeah, and then of course they can update the routes. Yeah, and then of course they can update the system. This is the class diagram. In this case, we try to look at how they can make it the distribution among the class. Yeah. So in this case, we try to limit only in user, tolls, and transactions. Yeah, where the user they can do one or too many transactions. Yeah, where each transaction can be happen in one or too many tolls. Yeah. So in this case, we can look at this is what become the attribute. Yeah, the user they have attributes such as username, user ID, user pin, balance, and vehicle type. Yeah, and they have a method such as user, top up balance, update vehicle, view balance, and user. Yeah, and then in class toll, this class should have ID, route, price, and they have some methods such as toll, update route, update price, and toll. And then in class transaction, we have attributes such as transaction ID and total payment. Yeah, and it has methods such as transaction, count payment, view transaction, and transaction. So literally, we try to make the implementation just only using 3 table database in this case, yeah, for the user tools and transactions. And this is the user UI for the user interface for the implementation. This is the main menu for the application where the user, but in this case, we just only making something like a prototype here. So actually we don't have the requirements such as the figure out about each of the requirement here, but this is can show how many top up that people can, the user that can do, yeah, what kind of top point they have. They can choose toll routes, yeah, commute, and point store that they can try to buy something or spend their vouchers, and this is the kinds of the voucher that they get have, or they can try to change their vouchers, yeah. And this is the optional start trip, yeah. This is there's related with the previous use case where can they try to look at what they can start, the position they can start, yeah. So in this case, we try to relate with Google Maps, yeah, so we can get the exactly what the position for the longitude and latitude for the presentation of its user when they use this application. Then of course they can choose the destination, and then they can give the short way how to reach the application. And this is we try to apply with the Google Map as well. So if we look at here, there's a red line here. This is something that what we call the bad congestion or traffic jam here, or there's a yellow here. This is something like what we call the needles. Yeah, if you already using the Google Map, you already know about this. Yeah, how to recognize between red and yellow color. Yeah, and of course based on the because you already try to install that application on your car or vehicle, then you already know about what kind of the price that it will be uh, submit to your cars. Yeah, so in this case there will be uh, the requirement that you how many that you can how how much that you can pay for the your journey here from start for the destination. Yeah. So you can start the trip, then the application will automatically to show you how you're gonna try to reach your destination in the simple ways. Try to reduce the number of time to go to your destinations. And also, this is the algorithm that we try to apply. This is the number of cars where the length of route will multiply with 4 and divided with the average car length. Yeah. For the formula, we have vehicle type constant with routes. Yeah. Price route and this mention the next route that will be accessed. Yeah. The price route one route that is currently crossed. Yeah. So vehicle type is a price for each route. Yeah, the total payment, price route one, price route n. Yeah. So this is mean that when we try to look at from one journey to another journey, this based on the destinations. Yeah, how many that they can try to go from some other place to other place based on the number of the toll gates. Yeah. So this is there's some requirement from the application as well, where the admin they should maintain the number of toll gate or toll exits. Yeah, how much. So this is can make decision how much that the user that should pay to go to the destination. So if you look at it, this is the algorithm that say that if we have a starting node such as A here, so people can, when people want to go to the final node here at the A, so this is they try to look at how many kilometers that they can go. For example, this the track here, but they need 4 kilometers here. They need move to the next gate here. They need 2 kilometers, and the other 2 kilometers they are the same, but they need the other toll weight. But there's some price here. Yeah, they have the different price. For example, here we go have starting A to the C. They have 3 kilometers, 2 kilometers, but in this case, we don't know exactly which one the best route for that. Yeah, because some other you already know that it could be there's some congestion or traffic jam between A and D or A and B or B to E here. So it's depend on the number of kilometers, not just only to show that this is the shortest pathway, yeah, or go to the destination. So for example, here user cross through 3 routes with different bill. The vehicle type is minibus. The minibus we have pay for 9,500 for the route first 9,500. So the route N plus route ones, yeah. So they can get the total payment here. The route one for 9,500 plus route two 15,500 plus route three 4,000, and this is become the balance become to 29,000. Yeah. So the total price that needed to pay by the user is 29,000 via the small tools our applications. Yeah. So this is the idea using the Jigsaw algorithm, trying to look at the shortest pathway. But in this case, like I said, not just only the shortest pathway, but at the end of the day, we should look at what the current situation on the traffic. Yeah, if there is a traffic jam or there's some congestion, and of course the pay that for each routes. Yeah. Okay, thank you for listening my presentation. I will look like happy if you have any question, you can send the question to my email. And if you look like to make a collaboration with me and my student, please. Yeah. Thank you. Bye.